Hey everyone, my name is Daniel Konigsperger, and today's workshop is going to revolve around data science and how we can use Python and some of its libraries to pull in data, process it, and then apply some basic machine learning models in order to extract some sort of valuable data and or predictions. Um, I think the easiest way to learn this is to first understand what's happening beneath the surface and so like how the predictions are made and why the models work. And second to that, and this is like the easy part, is to be familiar with how to manipulate the data in the first place, so that you can just throw it into one of Python's many data science libraries and let them do all of the heavy lifting for us. So what I'm going to be doing today is I'm going to show you guys a presentation about the k nearest neighbor machine learning algorithm and exactly how it works so that you guys can get an understanding for what's going on beneath the surface of one of the easier machine learning models. And I hope this will help that so that when we later use a library for it, that you can have like a little bit of an appreciation for what's going on underneath the hood and like what these libraries do for us. And after that, I'll go over an example from start to finish using Jupyter Notebook and some Python libraries rather than the code I show you in the presentation. Um, and a note I do want to make is that I won't be covering the basics of Python as a language in this workshop because most of the coding in the second part of the workshop is very specific to the libraries we'll be using, and it's very cookie cutter and easy and completely different to what you'd be doing if you were building everything from scratch, which I have a couple of screenshots that are from scratch in the presentation, but I'll kind of explain those in a non Python context. And at the end of this workshop, I'll also provide link to the presentation as well as documentation to set up your own like Jupyter Notebook environment and import my code so that you can play around with it and use it as a template to insert your own data and pick different models and go from there. So here we go. So in my opinion, machine learning is relatively simple if you think about it in the right kind of way. And a lot of machine learning reflects how we as humans make decisions, right? So when we struggle to understand certain models, it's always easier to see, how would we make these decisions in real life? And the k nearest neighbor algorithm is one of those models. That's very easy to understand when we put it in the correct context. And a computer is less intelligent but more powerful than a human. Um, it doesn't have a whole lot of intelligence, but we can ask it to do very repetitive and simple things over and over again without making mistakes. And so that's where some of these algorithms come in. They're very basic, but with a couple of more like complex calculations and a lot of repetitions, we can get them to imitate what we as humans, you know, do in our decision making. So imagine if hypothetically the basketball and track training rooms were together, and there's a new guy, right? Um, so UNC just beat Duke in basketball, um, and you congratulate him, right? So you don't know who this guy is, you don't know which team he plays for, but you can kind of see that he's a pretty tall guy. Up here, you see, the guys you do already know, the blue circles, and they all play basketball. And over here, you have a lot of guys that are on a track team, and you know how tall they are. And this new guy comes in over here. And so essentially what the k-nearest neighbor algorithm does, and usually how we would judge as well as humans, would be to see, like where does this new guy that we just saw fit in, usually we would look at a bunch of variables, but let's just say we're only looking at height. We go, oh, he's around the same height as all these other basketball players. He's probably a basketball player too. And the K stands for the K number of closest neighbors. So we take a look and we go, who are the closest neighbors? We say K equals 3. We look at the 3 closest guys. So this new guy, they all play basketball. So this new guy also must play basketball. So that's kind of how that algorithm works. And the way we determine how far our K neighbors are away from this new person to predict, what sport they play, for example, we use this thing called the Euclidean distance. And it's as simple in 2D as this equation. You guys are definitely familiar with this if you've taken some math classes. And down here, say you want to find the distance between a point in 3D space. That's the equation you'd be familiar with right here. And the more variables you add, you just add another difference squared underneath the square root. And so a simplified model of how we would go about these kind of problems, where you have a data set, you're trying to figure out some conclusions, right? The first step would be you want to clean your data. You want to make it, in the right form in order to insert into your model. The second would be to normalize. So as you'll see in a little bit, when we have a couple of different variables that we're trying to find the distance between, like we just saw in the previous slide, say age, the maximum age might be 30 and the minimum age might be 18, versus the maximum height might be 200 centimeters and the minimum height might be 150 centimeters. Those are on two completely different scales. And if we're trying to use both of those two variables together to predict something, then we also have to make sure they're proportional. So we would have to normalize those two variables, say between 0 and 1, so that now you can take the distance between 2 points with those two variables in mind. Thirdly, you construct the model, and then lastly, you can extract some value and make some predictions or get some analytics done. And this is an example of the code that I wrote. I'll link the GitHub later, but this is pretty much what goes on beneath the k-nearest neighbor algorithm. So this is essentially just the code for completing this calculation and figuring out the distance between your new record and an existing record. And this is what it looks like. And this is one of the examples I'll link. There we go. Okay. So I'm gonna run you guys through a brief demo in Jupyter Lab. This data set I found from the 2016 Olympic Games, and it gives a unique ID, it gives a name, nationality, sex, date of birth, height, weight, sport, and then the count of gold, silver, bronze medals, and an info tab. But as you can see, just by scrolling, we've only encountered one person that actually has this filled in. And we'll go over that in a little bit too, what happens when we encounter entries that have missing rows, that have entries missing. Okay, so let's go here. So the library, the two libraries we're going to be using are Pandas and scikit-learn. So Pandas is really useful for creating these things called data frames. They're essentially arrays beneath the surface, but they allow us to do a lot of complicated tasks in a very simple queries, like in one-line code, for example. So what I was talking about before, the base, like the from scratch that I wrote before, I had to do a lot of these things manually. For example, like if I wanted to change a whole column's type from an integer to a float, I would have to write a loop and change all of those individually, right? In Pandas, there's a very simple method for doing something like that. It's very, very simple, and it abstracts away a lot of the details. So we have the athletes.csv file. We have that in the local directory, so we can just reference that. So the first step is to clean our data, and we can take a look over here. So if we go We save it as a data frame. If we go dataframe.info, it gives us information about all of the data that's contained. So it converted the CSV file to a Pandas data frame. We can see here there are 11,538 entries. They are integers. Here we have some objects, we have some floats. Objects, I'd say they're essentially strings. You can treat them as strings. And down here, we can see that there's only 11,208 entries, 10,879 entries for height and weight. So it's pretty obvious that there's something missing here, right? And info only has 131, so we're gonna have to take care of that. That's one of the parts of data cleaning. Before you can insert your data into a model and get accurate results, you want to make sure that you have that you clean your data as best as you can, to get rid of, say, outliers, to get rid of missing cells, and all of those things, because otherwise when you run it, you'll have errors or you'll have inaccuracies. And so for this specific example, we're going to be trying to predict which sport an athlete is most suited for based on their height and weight and age. And so we're going to drop, just to begin with, we're going to drop the info, the gold, the silver, and the bronze columns, because we're not really interested in them. And so, like I told you before, this, Pandas makes everything super, super easy and with minimal syntax. So you just say drop, and then you provide all of the columns you'd like to drop. In place just means it's being performed on the same data frame that we currently have, so it's not going to create a new one for us. Okay, and then right here, I mean, I've obviously gone through this this example before while I was preparing it, and I've decided that our end goal is to predict which sport you play based on your height and weight. And obviously there are differences, between height and weight, females and males. And so, in order to make the predictions more accurate, right up here, I'm going to filter by the male, or you can type in female, whichever you like, to narrow down the results so that we're comparing the male weights and heights against the male weights and heights, and finding similarities between those, and the same for females. And so this is another example of a query, and then saving it back to the data frame that you can do in Pandas. And Pandas is super well documented. So literally anything you can think of, it's definitely been done. And I'd say Googling is like your #1 tool. So this right here will filter us down to only the columns that have the sex as female. And then as well as that, I tried this and I wanted to kind of show this k-nearest neighbor algorithm giving you very accurate results. And so I had to pick sports that would have differences in height and weight. And so I picked basketball, usually very tall, football, definitely not as tall as basketball players, and then golf, cycling, and rugby sevens. Rugby players tend to be pretty heavy and stocky. And so I wanted to see if, I was right, that those 1, 2, 3, 4, 5 sports had a bunch of differences in their combinations of height and weight that this algorithm would be able to pick up. And so in order to do that, in order to filter out just like I did up here, but to do that for a list of possible items, I can specify my options here. And then down here, I can say on this data frame in the column of sport, only include these right here if they're an option, essentially. And so our new data frame, when we run this, I'm not sure if we've run this, we run this, and now if we look at the data frame, you can see that we're only really seeing rugby sevens, football, golf, basketball, cycling, because all the other ones have been removed. And all of the sexes are now female as well, because we've removed those two. And info, gold, silver, bronze are no longer present. So I hope you guys can start to see that I'm narrowing down my data. I'm cleaning it a little bit to get to a place where I have a very solid data set that I can get some really good predictions out of. Okay, so the next step is to kind of fill in the blanks, right? Like we noticed before, a lot of these columns had missing values. And so, there are multiple ways of doing this. You can, if you only have a small amount of missing values, you can definitely just remove those rows, right? If that's not something that's important to you, but if you absolutely want to keep them, then something else you can do is we have a height column that's missing and a weight column that's missing some things. We can fill all the blanks we can fill all the blanks with the average height, for example. That's obviously not perfect, but I'd say it's a pretty good effort, right? Short of inserting a bunch of random numbers into the blank fields, we can figure out the mean of all the heights and the weight of all the heights, and then we can fill in all of the blank height slots with this average value. And again, in place means that we won't be creating a whole new data frame. It'll just be affecting the current one, which saves a lot of space. And I quickly printed out the average height and average weight just for reference to me, so I could see that it was doing it correctly. And let's see, we run dataframe.info, and we can see down here that everything's full. So obviously this is 815 now, down from what we initially had up here. But that's that's because we filtered by sex already. Let's see. That isn't a lot of entries. Let me see. Might be. Let me see if we can pick male to see if that would end up with more entries. Because the more you have, the more data you have, the more accurate your results will be. Okay, marginally more. Okay, they'll do. They'll be fine. That means that a lot of that means that a lot of them had the sex value missing. And so that's got to be a lot more of a tricky fill, right? You can't just fill in the mean, because it's either a male, or it's another category. It's not like a height and a weight, so it's a lot more difficult to fill in. So I guess what we essentially did by filtering male female, we essentially just took only those, which for this purpose is okay. So let's see. Okay, there we go. All right, and so like we noticed here, we only get the date of birth. This isn't something super important because at the end when we make some predictions, we can just plug in our date of birth, for example. But just to give an example of some things you can do, I wanted to change the date of birth to all of the athletes' current age, so that I could literally just plug in 22 and get back, which athlete I was closest to or something like that. And so right here, this statement right here changes the date of birth, all of those entries in that column, to a date time object. And if you do df.info, you'll see it's no longer an object or string. It's now a datetime object. And the reason I did this was because a datetime object, you can now get the difference between today's time and date and between this datetime object, and then extract just the year. So this is a little bit more complicated. You're applying a function to every single entry in this column, date of birth, and then we are storing it under a new column called age. X is just kind of like a place filler, so now we can, it's a place filler for the current entry that we're looking at. So what this function does is it loops over every single date of birth entry and applies the same thing. So it checks the current date and the current year, and then it takes the year from the date that we're currently looking at and subtracts it to get how old this person is. So if we run this and then we check date.info, we can see that we now have a new column called age, and it's just a number, it's an integer. And so once we have that and we're happy with that, we can now drop the date of birth one because we no longer need that. And as we can see, it's now gone and we're just left with the age. Just perfect. Okay, so step 2, we're going to fit our model to this data because we've cleaned our data as much as we wanted to. We filled in the empty entries and we're pretty happy. And so today I'm just going to be showing you one of the scikit-learn models that scikit-learn supports. So scikit-learn is an open source library. It includes pretty much every machine learning model that you could, or statistical model that you could think of. And I mean, the advantage to doing something like this, rather than what I was talking about the presentation, doing it by from scratch and showing you guys the Euclidean distance, how to get those distances and do the whole k-nearest neighbor from scratch, is you can use a library, right? It's pretty much a black box model. You plug in your data, you get out predictions, and that's that, right? And in my opinion, as long as you understand what's going on, that's good enough, because these right here are being supported by thousands of people. They are optimized to be super fast, and there's so many advances in computer science. You're never going to be able to understand absolutely everything and learn absolutely everything. So as long as you can understand what's going on, I don't believe in reinventing the wheel and spending all this time recreating a model when there's already a ton of libraries, another library be TensorFlow out there that you can utilize. So first, and this is typically what you would do with a data set that you're preparing to model, is you would split it up into a training and testing split. The training portion you would use to train the model, and then you would verify to see how accurate your model is on the testing data set. Usually it's an 80-20 split, but since I don't have a whole lot of data, I'm going to do a 90-10. So one of the things scikit-learn allows you to do is importing this thing called train test split. And so you provide a variable for your train data, like the train side of it, a test side, and then this function right here takes in the data frame, and you can give right here the test size split, so 10%. So this right here will just mean that 10%, I'm pretty sure it randomly does it, so say in case your data is alphabetically ordered or something like that, that it won't be biased, it will randomly, it will randomize all of the rows, so that you don't get a biased result. So it will split 10% into the test set and the remaining 90 into the training set. And when we check, let's run that first. And when we check the info to see right here. So before we had 1029 entries, and as you can see, we got 926 in the training data set and 103 in the test data set. So yeah. And then down here, this right here starts becoming, I guess, not 100% specific to the k-nearest neighbor, but it depends on the type of data you have and the type of model you're going to plug it into. Sometimes what you'd want to do is, if you were including, say, nationality as a variable right here, then before you're separating the labels into that and the attributes, you would want to, how do I explain this? You'd want to, it splits essentially, like instead of having nationality and all of these different nationalities down here, it would take away this column right here, and it would put every single possible nationality up top right here. And then it would just put a binary value, a 1, if your nationality is New Zealand, in the New Zealand tab, and a 0 for everything else. So essentially like the exact same as right here, the gold, silver, bronze, medal thing is. And the reason it does this is because most models like continuous data, right? So in order for the models to work, you can't have a nationality column with a bunch of discontinuous data. It doesn't work. And so you'd have to split it up into a bunch more columns, each with a 1 or a 0 in it. Okay, so over here, let's see, we said that we are going to try to use height, weight, and age. Let me see, I guess height and weight are more closely related. I had it correct the first time. We're going to use height and weight to see what kind of sport someone plays, right? So we're going to take 90% of all of the entries we have. We're going to look at their height and weight, and then we're going to see what sport they play. And then we're going to try and figure out some correlations between that, right? So that when we plug in, say, our height and weight, this machine learning algorithm will tell us which sport we are most closely matched to, based on all of these all of this 90% of data that has gone before us, essentially. So we're going to split that up. So we have the height and weight variables for the training data set, all of the sports labels for the training data set, and the same thing for the test data set. And this right here is what I was talking about earlier, the scaling part, right? So if you have age as one variable and weight as another variable, those two have completely different maximum and minimum values. Changing an age by one value means a lot more than changing a weight by 1 kilogram or 1 pound, right? It's a lot less significant for one than the other. So we have to make sure that each of these variables is scaled in a similar way, so that when we find the distance between 2 points, that we're not, if we found the distance between 2 points without scaling these, if somebody changed their age by about 10 years and changed their weight by 5 pounds, that distance would be very skewed. Like it wouldn't add up. Let me see if I can think of a better example to explain it. It kind of just, you can adjust this, as it should be, like importance-wise, but it gives, this right here will give height and weight equal weighting. It takes away the fact that the maximum height is probably around 210 centimeters, and the maximum weight is only around 100 kilograms, right? So it makes sure that both of these variables carry the same amount of weight in determining what this athlete plays. There we go. That's good enough. So this is also part of the scikit-learn library. This is how you import the minimum maximum scalar. It takes into account what the maximum value is, in this case of the height, in this case of the weight, and what the minimum value is, and then it scales it all down to proportion. I think between a value of 0 and 1, and same with the height and weight. I mean, both of these do the same thing, and so they both kind of carry equal weightage. One thing I should mention is, I'm pretty sure you can do this, but in the last step, right before you insert the data into the scikit-learn model, it's a lot easier to convert it to a NumPy array. So that's kind of like Python's array object, and there is a new version. So I think it's like 2 NumPy bracket, but I'm using an old version, so dot values is the equivalent. So this essentially changes these data frames to just simple arrays. It kind of it takes away one more layer right before we insert it, right? It takes away, up until now, right, we had a CSV file, then we put it inside a Pandas data frame to be able to clean all of the data. And now, right before we're about to insert it into the scikit-learn model, we're going to strip away that Pandas layer, because it's it's adding an extra layer on top that scikit-learn doesn't like. So we're going to take that away before we insert it. For the training set and the test set for X, so those are the 2 columns with height and weight. Those will automatically be converted to NumPy arrays when we do this scalar min-max scalar function. And so for the Y values, which contain all of the sports essentially, we have to do it manually. Okay, and down here we can see, right, so this is what looks like. So this is like the very this is what we get when we strip away the Pandas like fancy covering on top. Same over here. See, now we just get, over here we get normalized between 0 and 1, height and weight. And over here we get just straight up an array of different sports. And these should still be matching, right? So like the 0th one here should still match the 0th height and weight over here. And that order is really important, because we wouldn't want these mixed up, right? Because these are corresponding. Okay, and now we get to actually fitting the model. And so this is the Canary's neighbor classifier from scikit-learn. We import that, and we create a new classifier object. And right here in the name, the n neighbors, we can specify how many neighbors we want. So like I was talking about earlier with the basketball, UNC versus Duke example, when we pick n neighbors equals 5, we are saying that whatever prediction we put in, the algorithm will go and find the 5 closest matching items that it can find, pull their values, so their sports, and then see which one of those sports occurs the most, and that will be our predicted value. And then down here, this is kind of the step that will fit. And so we pass in xtrain and ytrain. So xtrain is the list, it's the 90% split of weight and height, and then it's the 90% split of all of the sports. So we run that. down here. So now that's run, right? The model's been created, and the third step is to make some predictions. And in this case, we're going to use the testing portion, the 10% that we left behind, to see how accurate our results my bad, our results really are. So classifier is the same name we had up here, predict, and we pass in all the x tests. So as you can see, up here we passed in x train and y train. We passed in the variables and what sport they correspond to. Down here we only pass in the variables, and we're going to let this model determine which sport they correspond to and see how accurate those are. So let's run that. And as you're starting to see, every time we import something, we have to do from scikit learn dot whichever subcategory is coming from import, and this one's a classification report. So I think you're starting to realize that scikit-learn has a whole lot built in, and there's a whole lot of different things you can do, anywhere from normalizing something to splitting a data frame in half or into 90-10 or 80-20%, all the way to displaying your results and kind of telling you how accurate your model was. And so this step right here takes our takes kind of the predictions, so the ones we predicted, and compares it against the labels. So up here we gave the last 10% of the height and weights, right? And we ran it through our model that was created up here to see which sports the model would predict. Down here we gave those results here, and we can now compare them to what they actually are, right? So it's going to look at these two and be like, are these the same? Yes or no? And then that should give us an output. So under the precision right here, it will give us the accuracy with which it could predict each of these 5 sports. And I mean, I've seen a lot worse results. I'd say this is pretty good. It was able to predict basketball very well. Golf was terrible, and cycling also wasn't so great. So I'm thinking basketball was probably so precise because basketball players tend to be so much taller than either of these other 4 categories, and so every time we saw a height that was probably above 200 centimeters, the algorithm was like, yep, that's closest to a basketball player. We've seen that before many times. We can confidently say that's a basketball player. So that's probably why. And so down here, we can do our own predictions. So the one thing we do have to look out for, and I made the mistake of forgetting this before, is that we can't just put in height and weight, right? Because remember, everything we have is all normalized, right? Remember, we normalized all these values between 0 and 1. So before we chuck in the one we want to predict, we also have to scale it to fit as well. We have to scale it between 0 and 1. So that's what this is doing. We scale between 0 and 1, just like we did for all the other ones before. And then we get the result, and then we can take a look. So I don't know, say I'm 180 centimeters tall and I'm 85 kilograms. Let's see what sport out of these 5 I would most closely align with. And cycling. Interesting. Hopefully it gives you kind of, at the very least, like a step-by-step guide to see how to utilize something like scikit-learn to split your data into a test and training data set, build a model, check the accuracy of the model, even if it's very inaccurate. You should always check how accurate it is so that you You're not just building the set and then passing it as if it's gold. You know where your flaws are, and then yeah, playing around with it for a little bit. Okay, and I think the number one thing to keep in mind when formatting your data and getting ready to build a model and make predictions is to know what your data represents and what kind of a model would be best suited for that data, right? What I picked here for the K-nearest neighbor algorithm probably isn't the best, like absolute best, model that I could have picked for, say, an Olympic data set or something. I'm sure there was probably a better machine learning model or statistical model I could have picked, but I picked this one because it was very easy to explain. It showed how the scikit-learn library works and how you can input a data frame into it and get out some results and measure the accuracy. That was the main purpose. Um, but you should always kind of adjust the model to the data, not the other way around. So for example, in this case, we only used height, weight, and age because you can be close in height or weight or age to someone, but when it comes to nationality, you are either that nationality or you are not. So unless you want to do the conversion I was talking about before with that, you should probably pick a different model if you're trying to include non-continuous data. And another example, we say we had a number of variables that weren't continuous, like the color of a car, its like exterior, body type, and brand name. Then maybe like a more complex model, such as like a decision tree, might be better suited, like to accurately predict the outcome. So that pretty much concludes the workshop. I hope this has been helpful. I hope it wasn't too confusing. My main intention was to kind of just give a little bit of a background beneath one of these algorithms, so you could see that it's not all that difficult, that it makes a lot of sense when you look at it the right way, and then also just to show you something like scikit-learn and how we can make machine learning very easy and very accessible to everyone, really. And mostly the only difficult thing is picking the right model and cleaning your data appropriately so that it fits into that model. And so next week I'm going to be putting out another video, but this one we get more towards some basic natural language processing and web scraping. So look out for that one, and please reach out to me if you have any questions, and let me know if you're thinking of working on something similar for your DSC solution challenge submission, and I'd be more than happy to help. Thanks a lot for joining.